I want to talk about how ClickHouse stores data. Now, this is going to be a very quick sort of run through of terminology, but you got to understand it. Like, I need you to understand all this information. And so when we talk about how ClickHouse stores data, ClickHouse uses something called a table engine. And a table engine is, every table has to have one. And we got lots of table engines. If I go to the docs and I go to the SQL reference, you can see we have a whole section of table engines and they look good. Like if you got data sitting in Hadoop, there's a table engine for that. If you got data coming in from Kafka, there's a table engine for that. If you got data sitting in Postgres, there's a table engine for that. What does that mean? What does that mean to use the Postgres table engine? What it means is that you're going to leave the data in Postgres. The table engine dictates where the data is stored. You can leave the data in Postgres and query it all day long in ClickHouse using this table engine. Is that fast? I don't know. It's not going to be very fast. It's not going to be super fast. It's going to be okay fast. But if you want it to be really fast, if you want the full benefit of ClickHouse, you've got to put the data into ClickHouse in a merge tree table. That is a family of table engines called merge tree. That's the payoff. That's the column storage. That's the scaling of the processing of the data. It's the sharding and the replicas that all comes from merge tree. So that's the payoff. When it's time to put the data into ClickHouse, we use the merge tree table engine. So my little question here, which table engine should I use, is this one. And for what it's worth, this very simple table with 3 very boring column names, column 1, 2, and 3. The engine is merge tree. Notice the sort order is column 1 and column 2. Column 1 is going to be a character, a fixed string, and column 2 is just a number. Yeah, you put the engine clause after the column list. So, okay. So this is my ClickHouse table right here. By the way, merge tree is the default engine nowadays. You can leave that off. But what's interesting is, and now hang on, because you got to understand this. And in the other trainings, I spend way more time than I'm going to in here on this one, because this is kind of the focus here is how to set up a cluster. But you can't get anywhere in ClickHouse without understanding the primary key. It is the most important fundamental aspect of ClickHouse is to understand how primary keys work. If I go back a slide, I had order by column 1 and column 2. Here I put primary key column 1 and column 2. There is no difference at all. It's syntax. Behind the scenes, they would be the exact same table. There is no difference between the order by and the primary key in a merge tree table. And it's not unique. Primary keys in ClickHouse are not designed to be unique. They are not unique at all. You can put in 10 million rows that have the same primary key. We do that all the time. And ClickHouse will be very happy with that. In fact, that's a great situation, by the way. It's lovely when you can have 10 million rows with the same primary key. So keep that in mind. We're not a transactional database. We're not finding one row and changing one value. This isn't ClickHouse. We're putting in a lot of data so we can analyze it. Okay? And there's a reason for this primary key, and I'm going to show you. When you insert a bunch of rows, this insert would work on pretty much any database out there. This is your standard SQL insert. Notice I inserted, it looks like 8 rows. Every time you do an insert into ClickHouse, you get a new folder called a part. If I go back over to my UK price paid and I look at this folder, go back one. I have, they merged in the background. Oh, while I was talking, there's only 6 parts. But before, I had way more than 6. I had like 20 some. Oh, that's really funny. So 5 minutes ago, I had like 20 some folders when I listed the folder UK price paid. Now I'm down to 6. And notice they used to all end in 0, but now 4 of them end in 1. What does the 1 mean? That means a merge happened and we're 1 level down. These 4 folders are 1 merge into their lifetime. Okay. Every insert creates a folder on your file system. This has to make you a little concerned. If you're going to insert one row at a time, for example, you're in trouble. Well, we don't insert one row at a time. We insert tens of thousands, hundreds of thousands of rows at a time, maybe a million rows at a time if we can. And if you do have to insert one row at a time or 10 rows at a time, you're going to be in trouble. You're going to turn on a feature called async insert. You're going to Google that really quick in the docs, search the docs, and you'll find the page on it. So that ClickHouse buffers those into bigger parts. You don't want too many parts. So I do this insert with 8 rows, and only the 8 rows go in there. So inside this folder, by the way, the primary key was column 1 and column 2. So all that, and the column 1 and column 2 were just A's and B's and 1s and 2s. So all the A1s are going to be first. If you sorted them alphabetically, numerically sorted. A2 will be next, then all the B1s and all the B2s. That's how the rows are going to be sorted. And then there's this weird primary.cidx, whatever that file is. It's only got one entry in it for some reason. Well, we'll talk about that. What I want you to understand right now is this part concept and these files inside there. Now, you don't always get separate files. You don't always get a column file for each column. If you don't have very much data, if you have a small data, we store the data in what is known as the compact format. And instead of having column files, you know, if you only got 1 million rows or 100,000 rows or something, we'll just store it all in one file because it's more efficient. Once you get to a certain point where you have a bunch of rows or a lot of data in terms of size, that's when ClickHouse starts storing your columns into separate files. We call that the wide format. And there's settings for that. Minimum rows for wide part, minimum bytes for wide part. So you might see everything in one file. I didn't. I saw everything in multiple files. If I went into one of these folders, if I go into the all 13 part, which by the way is inserts number 13 to 18, you can actually see that's actually what those numbers mean. And the 1 means they got merged. And I look at what's inside there. Yeah, this is the wide format. Every file has its own, or every column has its own file. So, all right, so I just want to point that out. And you can change those values. I haven't shown you this yet, but you can always put settings at the end of a, you know, at the end of a table definition, at the end of a query. We put this settings command, and then you can define whatever your settings are. So, all right. So you can decide when ClickHouse decides to split apart your columns into separate files. All right, so what's happening is these column files, notice they're named after the columns. It doesn't take 10 billion rows and compress them. What it does is it inside those column files are blocks. They call them compressed blocks. And, you know, they're somewhere between 64K and a megabyte. Well, don't worry about that. This isn't anything you need to worry about or even think about. It's just something to be aware of, that it's one of the reasons why ClickHouse is fast. We don't compress everything. And then if we compressed it all into one big thing, we'd have to uncompress. Every time you ran a query, we'd have to uncompress 4 billion rows or 10 billion rows or something. That wouldn't be very efficient. So there's these blocks inside there. Keep that in mind, because I'm going to talk about, we'll come back to that just briefly. These part folders, obviously something changed when I did the UK price paid here on my laptop, and they kind of merged into fewer folders. Well, that's what ClickHouse does. If I'm inserting 1 million rows per second, I'm getting a new part every second. That's not sustainable. Every minute, I'm going to have 60 folders. Every hour, I'm going to have 3,600 folders filled with files. I'm going to have thousands and thousands of files on my file system. That doesn't even make sense. Over time, the parts merge, and they keep merging. As they merge, the old parts get deleted. But they just, so you're still, you know, I'm still inserting 1 million rows per second. I'm getting new parts every second. And then what? In the background, they're just merging and merging and merging. So do they merge forever into one big folder? No. Once a part folder has 150 gigabytes of files in it, then we stop merging that part. 150 gigabytes, that's a lot of rows. My 27 million rows of UK property prices, was only 400 megabytes. I mean, I could put billions and billions of rows into one part if that was the default setting for my UK price data. So keep that in mind. That's a very substantial number. You can change it if you want, but look, ClickHouse has been around for a long time. These settings are, the defaults are probably fine. All right. So I've got these part folders, and inside that part folder, we saw this little primary index file. Well, every merge tree table gets one index, and that one index is called the primary index. And what does it contain? Look, we store your data into compressed blocks into files. That's a very physical thing. That's how your data is physically stored. But what ClickHouse does, this is very clever. The whole idea behind this is very simple, but super clever. We take your 10 billion rows and we back up and we look at them logically. Now they're sorted by the primary key, which in my example was column 1 and column 2. And I had some pretty simple data. I had A's and B's and 1s and 2s and whatever. Look, if I had millions and millions of rows of this, what ClickHouse does is it logically looks at those millions of billions of rows as granules, where a granule is 8,192 rows. Interesting. Where did that number come from? Well, hang on. It's an interesting number. It came out of just, what, 15 years of general use of ClickHouse and thinking this is a pretty good size for a granule. What's the purpose of a granule and this primary index? The primary index is the first row of every granule. Again, this isn't how your data sits on disk. It's how your data is logically viewed by ClickHouse. The primary index keeps track of the first row of every granule. So row number 1 in my fictional data set here looks like it's A, 1. Why is row number 8,193 special? Well, it just happens to be the first row of the second granule, which is also A1 in my fictional drawing. Why is row 16,385 special? Well, it just happens to be the first row of the third granule, which in my example is A, 2. And the fourth granule starts at row 24,577. That just happens to be a B1 in my example. What's the point of that? Look, if I write a query and I want to filter by column 1 and column 2, and I want column 1 to be A, and I want column 2 to be 2, look at this primary index. Look at what this index does for me. A, 2, I can skip the first granule. I can skip 8,192 rows right out of the gate because I know there's no A, 2s in the first granule. I don't know about the second granule, but the third granule for sure has A, 2. I'm definitely gonna have to process the third granule. And the real payoff is right here because I can skip the fourth granule. Not only can I skip the fourth granule, I can skip every granule after that. By the way, I have 27 million rows. 1, 2, 3, 1, 2, 3, divided by 8,192. My UK property price data has about 3,300 granules. That's a pretty small data set, 3,300 granules. But man, can I skip a bunch of granules? If I had thousands and thousands of granules and I only had to process 2 of them, hey, that's a nice payoff. That's a beautiful payoff. So, by the way, I have to process granule 2 because there's potentially some A, 2s at the end of the second granule. This granule is the smallest piece of data that ClickHouse even bothers with. ClickHouse never reads one row of data, ever. ClickHouse always reads 8,192 rows at a time. Now you can configure that. Every table can have its own granularity. But like I said, I can't even think of a reason why you change it. You're not going to change it at the beginning. You might change it a year from now when you discover something clever about your data, but I sure as heck wouldn't change it anytime soon. So you've got this logical view. These granules are logical, and the blocks, the compressed blocks, are physical. So how do they find each other? Well, there are these extra files called mark files, and we saw them. Every column file, street.bin, has a mark file. It's called .c mark2. They changed the extension every couple of years. That extension seems to change. But anyway, that's what the mark files do. So the primary index knows which granule to process. The mark files know where those granules sit inside the part folders. And so that's why those mark files exist. So here's a very convoluted picture. If I search for B, 2, look, the primary index is like, hey, I need these granules. And the mark files are like, hey, I know exactly which block to open up. You open up the block, then you grab the granule. This happens so fast. Look, I ran that query. I'll run it again. What was that query I just ran? I just processed 27 million rows over 3,300 granules, and it took 244 milliseconds. That's pretty fast considering all the things that are happening in the background. So these granules, when you grab like a bunch of columns and the granules get processed, if you grab more than one column, they get put together in what we call a stripe of granules. But what's super interesting, and one of the reasons why ClickHouse is so fast, yes, column storage makes ClickHouse fast, but the concurrent processing of granules also makes ClickHouse ridiculously fast. If I have to process 3,300 granules, how does that work? Each stripe of granules gets passed to a thread. The threads are just sitting there in a pool of threads waiting. If I have 128 CPUs, I could, in theory, run 128 threads at a time. And so ClickHouse is very quickly passing those granules, those 8,192 rows, to a thread. That thread is very quickly finding a CPU, doing its task on 8,192 rows, and then coming back and giving the result back. And it all gets combined. And if any one of those threads is too slow, then another thread will steal that granule and try to process it faster. This concurrent processing design is why ClickHouse is so fast. We don't do one row at a time. We process 8,192 rows at a time. And one last comment about just something to be aware of in ClickHouse. Because the primary key is so cool and so efficient for filtering and throwing out granules, we don't recommend you partition by things like postcode 1 and postcode 2. We would never partition by that in ClickHouse. We only recommend you partition by month, and that's for data management purposes. So we don't recommend a partition key at all. You get too many parts. Only rows with the same partition key can go into the same part. If you partition by customer ID and you have 1 million customers, you'll have 1 million parts. And that's way too many parts. Your cluster won't even run if you get 1 million parts because it exceeds the maximum, which is 100,000 parts. That'd be a bad idea. We use partitioning for moving data around, dropping partitions, deleting partitions, moving partitions, but we do not use partitioning for skipping data. That's old school. That's your old database way of thinking. In ClickHouse, you pick a good primary key. Why do you need to know all this? Because you need to know what a granule is. You see the word all the time. Parts are so important. You don't want too many parts. Too many parts is often the error of a design decision. So you got to pick a good primary key, make smart inserts. It's really important to understand the terminology. So when someone says, what's a good primary key for a table? There's no single answer. That's a poorly worded question. The question should be, what do my queries look like and what am I filtering by? And if I filter by town or county, yeah, that should be my primary key. And if I filter by town and date, then town and date should be my primary key. It's what your where clauses look like. So, all right. So keep that in mind. And a very nice lab.